Hey, Patrick Sullivan here, and I want to contrast the difference between subtracting integers when you have enough in the whole, enough of a unit in the whole to perform the action, and when you don't have enough. So let's start out with a more challenging case. Let's say that in this particular case, we have 8 blue units, and we want to remove 3 red units. Now, the problem is we don't have 3 red units, but this unique relationship between red and blue units is that they're essential. When we combine a red unit and a blue unit together, it equals 0. So in this particular case, we're going to add what we call 3 sets of 0 or 3 sets of 0 pairs to the whole. Now, remember, the whole was 8 units of blue. So now we have 3 units of blue, and we have 3 units of red, which together is 0. So we haven't changed the amount in the whole. Now we're going to remove the 3 units of blue, excuse me, 3 units of red. And now we're left with 8 and 3 units of blue, which is 11 units of blue. So I'm going to change it up just a little, and I'm going to tell you that a unit of blue is a unit of 1 and red is a unit of -1. So think for a moment what subtraction problem we just solved. So in the whole, we had 8 units of 1, and we needed to remove 3 units of -1. And that resulted in 11 units of 1. So we just completed the subtraction problem. 8 minus -3 equals 11. But what if red was a unit of 1 and blue was a unit of -1? So in this case, the whole was 8 units of -1 or -8. And we had to remove 3 units of 1, but we didn't have them. So again, we added the 0 pairs, which we did, and we removed the 3 units of 1, which we did earlier. And we're left with subtraction problem. -8 minus 3 equals -11. And in my world, I would call those analogous problems because the quantities were the same, the actions were the same, but the units were different. So this was an example when there was not enough of a unit in the whole to complete the action. So now let's look at enough of a unit in the whole. So in this particular case, we have 8 units of blue, and we're going to remove 3 units of blue. Once again, we're going to let blue represent a unit of 1. So in this particular case, we had 8 units of 1 and we removed 5 units of 1. So we have the problem 8 minus 3 equals 5. So we had 8 units of 1, we removed 3 units of 1. Now we're left with 5 units of 1. But what if it's a unit of -1? Well, we had 8 units of -1. We removed 3 units of -1, and we're left with 5 units of -1, which is modeled by the problem -8 minus -3 equals -5. Once again, we have two what I call analogous problems because the quantities were the same, the actions were the same, but the units those actions were applied to were different.